If I put 1 in, what will I get? I'll get 1. Let's put in 2, what will I get?
1/2.
If I put in 3, what will I get?
1/3.
If I put in 4, what will I get?
1/4.
Remember, class, I'm trying to go to infinity. I'm trying to make it get larger and larger. So for the fun of it, let's get a little larger. If I put 10 in, what will I get?
1/10.
I get how much?
1/10.
I get 1/10. Now, I know y'all had another way I can write 1/10. Y'all had this in the what grade was that? Probably 3rd, 4th grade. What's another way I can write 1/10? In decimal form. That's what now? So they saying that's 0.1. If I put in 100, class, what will I get? Which one you want to give it to me? Give it both ways, Miss Hill. She says this is 1/100, or this is the same as 0.0 what? And that class, I suppose I put in 1,000. Remember, class, I'm telling you, I'm trying to go to where, class? I'm trying to go to where? Infinity. I'm getting larger and larger. And hopefully y'all realize I get 1/what? 1,000? Which is the same as 0.00 what? 1? We good? Now if I put in 10,000, we know I'll get 1/10,000, which is 0.000 what? 1? Now leave out a 0. 1,000, and we good, class? Now, class, if y'all do this, where is this number you getting close and close into? Where does this number go into? Anybody know? So the limit as x goes to infinity for 1/x is equal to 0. And y'all should see this by the graph. Look at the graph, class. If I get larger and larger, please getting closer and closer down to the x-axis. It's getting closer and closer into what? 0. If I do it the same way, now class, if I ask you to find the limit, as x goes to negative infinity, the 1/x. Hopefully you realize I can just change these to negative numbers. We good, class? Instead of being positive, they all gonna be what, man? So where do you think the limit as x goes to negative infinity 1/x? Look at the graph, class. Where's it going to? So do y'all also realize it's going to what? 0? Yes, no? So therefore now, class, if the denominator gets larger and larger, the fraction has to go to where, class? 0. Did we have this earlier this year already? If the denominator gets larger and larger, the fraction has to go to where? 0. So that brings about our next definition. And it says, the line y equal to L is a horizontal asymptote of the graph of f if the limit as x goes to infinity of f of x is equal to L, or the limit as x goes infinity of negative infinity of f of x is equal to L. So what we basically telling you, class, when I have this graph y equal to 1 over x, you have a horizontal asymptote right here at 0. In a similar case, you have a horizontal asymptote here at 0 also for the vertical asymptote. In the test we had last time, we showed you want to find the vertical asymptote. You said the denominator equal to 0. If you want to find the horizontal asymptote, you take the limit as x goes to what? Infinity. Do my class understand this by simply looking at the graph? Or if x gets larger and larger, the denominator gets what? Larger and larger. We good? So I'm going to put this little problem on the board. And I want to find the limit as x goes to infinity for 5 plus 1 over x. Now, if y'all know we had the limit properties. This is the same as the limit as x goes infinity of 5, and plus the limit as x goes infinity for 1 over x. When we talk about this, class, we can just separate it because plus or what? Minus. We good, class? Now we had this earlier. What's the limit of a constant?
0.
The limit of a constant.
Derivative. Oh, it's a constant, yeah.
It's the constant. So I don't care what you put in here. You still gonna
Yeah.
get what, class? 5. What's the limit as x goes infinity for 1 over x?
2.
This is 0. So what's the answer, class? See how easy this is, class? So now, class, we gotta have the guidelines for finding the horizontal asymptote. Yes, ma'am.
Could you do another example? Please?
Why would it be
So
0?
now we have the limit
Why would
is x goes infinity. So I want to get 3 all over x.
it's not a constant?
We'll put the 5 up. Are we good, class? So y'all remember we had the properties, yes, no, class? This 5 is nothing more than being a constant, because this could be the same as 5 times the limit is x goes to infinity for 1 over x. Remember that 5 is just what? A constant? So in that case, in that class, we'll get 5 times how much? We'll get 5 times how much, class? Why? Because this part here we know is going to go to where, class? 0. So the answer is, so anytime the denominator gets larger and larger, then the answer will be 0.
Wait. So it's not equal 0?
I'll check and make sure y'all can pay attention. What's the answer supposed to be, class?
0.
Very good. What's your name?
Yes.
You good, Miss Joanna?
Yes.
Um. So let's go back to this. Finding limits at plus or minus infinity of rational functions. Now, what do you mean by a rational function? That's when you have a numerator and a what? Denominator. So that means, note, for a rational function, that's when we have f of x, I have some numerator function, and I have some what? Denominator function. You good, class? Rational means you got a fraction. You good, class? And this is the first one. If the degree of the numerator is less than the degree of the denominator then the limit of the rational function is 0. And let me show my class how easy this is. You ready, class? This is so easy, and even a first grade can do it. You ready, class? You ready? So I have the limit as x goes to infinity, and I have 3x cubed minus 7x squared plus 9x all over 4x to the 5th plus 6x squared plus 11. And I want to find the limit of this. What you really have to do is let this number get larger and larger and larger, top and the bottom, see what's going to happen. But they're saying you can actually just look at it. It says if the degree of the numerator is less than the degree of the denominator, then the limit is how much, class? 0. We good? So let me ask you this question. What's the degree up here? What's the degree of the numerator?
3.
What's the degree of the bottom?
5.
Is it less?
No.
So what's the answer? Now, can we all do that, class? So you just look at it. Look at the top, look at the bottom. Where's the smallest one? On the top. So the answer is how much? 0. We good? And let's see the next one. It says, if the degree of the numerator equals the degree of the denominator. Then the limit of the rational function is, they write these fancy words, the ratio, anybody know what ratio is? Of the leading coefficients. So let's see how easy we can make this. Y'all ready? Ready for an example, Miss Davis?
Yes, please provide an example.
Let's provide an example. Miss Davis, what's the degree of the numerator here?
You said the 3, right?
Okay, Miss Davis, what's the degree of the denominator?
I think it's supposed to be a 5. Or a
Help her out, class. What's the degree of the denominator?
3.
The highest degree in the top is 3. The highest degree in the bottom is what? 3. They are what, class? Are they equal?
Yeah.
So therefore, they say it's the ratio. What does the ratio mean?
It's 3.
It's the ratio of the leading coefficient. What's my leading coefficients?
3.
So therefore, this answer will now be
3 over 3. So, oh. Okay.
now, I got problems. You can't look at the top, look at the bottom and see whether one is less or equal. We good? Let's try another one. I have the limit as x goes infinity of 2x cubed minus 6x squared plus 9x all, let's make it to the fourth, all over 3x cubed minus 7x minus 2x to the fourth plus 11x. We'll throw some minuses in. It doesn't matter what it is. So y'all help me out. What's the degree of the numerator? What's the degree of the denominator? What's the degree of the denominator?
3. 3. 4.
What's the degree of the denominator?
It's 3. It's 4. It's 4?
Oh, 4.
Why?
Because it's 2 sides.
It's not gonna always be put in order, class. You just look for the highest one. Please note the highest exponent I got here is 4. The highest exponent I got here is also what? 4.
4.
You good, class? So are they equal? Yes, no? So what's the answer to the problem? Huh?
4 over 3?
Oh, no, 2 over 3, sorry.
Can I tell you what the answer to the problem is?
2 over 2?
Can I tell you what the answer to the problem is?
What?
Depending on you, Mr. Wilson.
Is it not 2 over 2?
Leading coefficient of the whole equation or of like the highest degree? Because over there is the highest degree in the person.
Okay, you gotta understand what they mean by the definition of the leading coefficient. So I'm gonna tell my class this is 2 over what?
Negative
The
2.
leading coefficient is the one with the highest exponent. We good, class?
Why is it
Because
Because of the
this is
subtraction.
degree 4. So I'm looking at this, and I'm also looking at what? This. Doesn't matter because they aren't in order. Everything's not being ordered for you every time. We good? So the answer is 2 all over negative 2, which is?
Negative 1.
We good, class? I'm just trying to make sure y'all paying attention. We good, class? Now the third one says, the degree of the numerator is greater than the degree of the denominator, then the limit of the rational function is, well, does not exist. So for to find it, if I change this to a what's my degree of the numerator here, class?
3,
Denominator.
2,
Which case does it fit? The first, the second, or the third one?
the third
So what's the answer to this one?
does not exist.
All we have to look at the degrees. Now you should know which one is. We good? So let's do 3 problems real quick. Find the limit. I have the limit as x goes to infinity of 2x cubed minus 6x squared all over 4x cubed minus 11x. I have the limit as x goes to infinity of 4x to the squared plus 6x all over 3x cubed plus 11x squared. I have the limit as x goes to infinity of 4x cubed plus 6x squared all over 11x minus 6. What's the answer to the first one?
1/2.
How'd you get 1/2?
Because the 3 and 3, because of the
How'd you
x
get it?
cubed.
The degree are equal, and since they are equal, then we'll take
1/2.
2x over 4x. But it's only 2 and 4, so
1/2.
1/2.
So this and you look at the top, look at the bottom. This is degree 3 and this is also what? Degree 3. So use what class? The coefficient, which is 2/4, which is what? 1/2. What's the answer to this next one?
0,
Why?
because the degree of the numerator is
The top is less than the bottom, so the answer is what? 0. What's the answer to the last one?
Does not exist.
Why?
Top is greater than 1.
The top is greater than the bottom. So how easy this is, class? So we can do stuff like this now. Find the vertical asymptote and number 1 says f of x equals 3 all over x plus 1. Now I want to find the vertical, I want to find the horizontal. No. Yeah, let's find the vertical and horizontal. We had this on the last test, didn't we, Mr. Harris? How we gonna find the vertical asymptote, Mr. Harris? Anybody, how you find the vertical asymptote?
X plus one.
Huh?
Minus one.
I can hear you. What equals zero? Huh? It's a little louder, and
The denominator.
not quite. Help us out.
The denominator.
Assume we just set the denominator equal to what? Zero. So the vertical asymptote, we're gonna set. So that means that x plus one is equal to zero, so x is equal to what, class?
Negative 1.
See how easy that is, class? To find the horizontal asymptote, what we do? That's when we take the limit as x goes to what? Infinity. What's the limit gonna be here? What's the degree in the top?
The degree.
What's the degree in the bottom?
1.
So y'all know that this degree is 1. You understand why it's 1, yes or no?
Mm.
What's the degree up here?
1.
This degree is 0, class, because x is not raised to any power. We good, class?
Oh, never mind.
So what's the answer to the problem?
0.
So therefore, the horizontal asymptote will be y equals what? 0.
So glad I got that.
To find the horizontal asymptote, you take the limit as x goes to infinity. Horizontal is y equals, vertical is x equals. So all we see in class, if you sketching this graph, what you already know ahead of time is, you're gonna have a vertical asymptote at what? There's a vertical asymptote at -1, and there's a horizontal asymptote at what? Now, I'm guessing this graph is gonna look something like this. I know this, because I know the vertical and horizontal asymptotes. To find the vertical asymptote, you just set the denominator to 0. To find the horizontal asymptote, you take the limit as x goes to infinity. You can just look at the degree in the top and the degree in the what? In the bottom. We good? Now, we had this problem on our last test. Did we have some problems finding the horizontal, vertical? So, now let's pose this is number 2. And I have f of x equals, what do we have on that test? We had x plus 11 over x squared minus 4x. X plus 11 all over x squared minus 4x. So we just told you to find the vertical asymptote. What do you do?
Set the bottom equals 0.
So that's x squared minus 4x equals 0. How can I solve this? How you gonna factor this? So it's x times.
X minus 4.
Now what you do now?
Set the, yeah.
So that's x is equal to 0, or x minus 4 is equal to 0, which means x is.
4.
So that means, class, this is what I know if I start sketching this graph. How many asymptotes I have here?
2.
I got one over here at, no, I got one at what? 0? And I have one at where, class?
4.
4. Now, how you find the horizontal asymptote?
Set equals to negative.
That's when we take the limit as x goes goes to infinity of x plus 11 all over x squared minus what? 4x. What's the degree in the top?
1,
What's the degree in the bottom?
2,
So what's the answer?
1/2. No?
Zero.
No, wait.
What's the answer?
Zero.
Why is it 0?
Because the degree in the numerator is.
That's the
less.
first case. If the top is less than the bottom, the answer is what?
Oh,
0. So the horizontal asymptote will be y equals what? 0. So when I start sketching this graph, I know I have an asymptote right here. We good, class? Yes, no? We may as well do one more. We ready, class? Let's do number 3. It says f of x equals, I don't know, x squared minus 4 all over x squared minus 4x plus 5. I want you to find the horizontal asymptote for me. Let's do this. X squared minus 8x. So for the horizontal asymptote, remember that's when we take the limit, is x goes to infinity of x squared minus 4 all over x squared minus 8x plus 5. Can y'all just look up here and tell me what the answer to this is?
1,
How much?
1.
How'd you get 1?
Because they're the same degrees.
So y'all realize this is the same degree, both of them are 2. We just look at the coefficients. This is 1 and this is also what? 1. They just not written down. We good? So the horizontal asymptote will be y equals what? What about the vertical asymptote? That's when we say x squared minus 8x plus 5 equals 0. How are we going to solve this?
Move the 5.
How are we going to solve this? Miss Sandy, how are we going to solve this?
Oh, wait. Do that.
Go to subtract 5 both sides. And then flip it
So my college, sophomores and juniors and seniors in here, how do you factor x squared minus 8x? Nah,
10 and 2.
we can't factor this, so what you gotta use?
No, I hate that.
What you gotta use?
Quadratic formula.
You gotta use a quadratic formula. We good, class? So they see and they can't factor this. So how many people know the quadratic formula? You ready, Mr. Harris? What's quadratic formula?
Plus or minus. B.
All right, Miss Ali, you wanna give it to us? We good, Miss Ali? Miss McNamara, what you got?
Is it B plus or minus?
Oh, I got a college,
Lord, I can't remember.
sophomores, juniors, seniors. Can't tell me.
B
the
plus or
quadratic
minus
formula.
the square root of B squared minus 4AC over
Say,
2A.
What is it then? I'm listening.
You said B plus or minus square root of.
No.
Okay, well.
Plus minus square root b squared minus.
Negative what?
Oh,
Oh.
B
Uh-huh.
plus minus square root b squared minus 4ac all over 2a.
You good, class? Now, y'all see the problem we're
Yeah, I'd
having,
be
man?
pretty negative
And
for
y'all-
you.
Any freshmen in the house? Oh man, the freshmen in the phone and y'all did, oh, I'm sorry. We good? Huh?
Fresh out of school, of course he gonna know it. It's 3, 4 years.
So let me ask you this question. When you get that job, you gonna look at your boss, he or she, or he, she, or whatever it is, and you gonna tell them, I can't do this without.
My job has nothing to do with me.
Oh, does it matter what it is? Yo, does it matter what it is? You can't look at it and say, he just had this. Frank as hell. Oh, he fresh out. Where'd you go to school, sir?
Hmm?
Where'd you go to school at?
J.D. Clement High School.
Let me move on. So here we go, class. So we have equals. What's A? What's A? What's A?
1.
That told me A is 1. What's B?
-8.
What's C?
5.
So what happens is I got -8? So that's 8 plus or minus the square root of
64.
64 minus
20.
all over.
2.
So that's 8 plus or minus the square root of
44.
all over, which is 8 plus or minus.
I gotta look at my calculator.
Somebody told me 2 times the square root of 11 all over 2. Okay, class. 44 is 4 times 11. We good, class? And the square root of 4 is 2, so you can take the 2 out. We good? Now, my class understand why I can reduce this and get this to be 4 plus or minus the square root of what? 11. I got 2 answers. We good, class? So one of them would be x equals 4 minus the square root of 11, and the other would be x equals 4 plus the square root of what? 11. We good? Yes, ma'am.
Does the negative, is that negative times -8
We're right here?
for the B? Yeah.
Yeah, that's when this -8 went to positive right here. We good? So therefore now, my class can find the vertical asymptotes and they can find the horizontal what? Asymptotes. Can we not, class?
I guess.
So let's pick one problem. This is what y'all have to go on the test. You ready, Miss Davis?
When did you say the test will be?
When you want it?
Next week.
Next week?
We can do next Thursday.
Wait, the retake?
Can you provide us with another, study guide for your last time? That was very helpful.
It was very helpful?
Yeah, it is.
Sure. I could.
Oh, okay, well,
It would be very nice. It would be very nice to do Wednesday, but I don't want to do Wednesday.
I want all my students to pass the right way. Start studying it. Learn the formula for the rest of their lives. So it may say given f of x equals, let's make up something beautiful here. The book should have one in here. Cause all my class been doing their homework, haven't we, class? That's a beautiful one here. X to the fourth. Somebody might tell me that's too much work. Which one was in class yesterday? Anybody remember?
He said that.
Let's do this. F of x is equal to 2x to the fourth minus 8x cubed. Find all critical points. If you can do this, you have no problem to test next week. We good? For most part. We good? How you find critical points? Critical points. Oh, let's do this. We know we do this. We're gonna find all critical numbers. How you find critical numbers? Help me out, Miss Deanna. How you find critical numbers? Okay, what's the derivative, Deanna?
So you're going to do 2 times 4, which is 8x to the third, and then 24x squared.
All right, you got the first derivative, we're gonna do with it.
Said he uses 0.
I said equal 0, we're gonna do with it.
Factor.
How you gonna factor it?
Factor out 8x squared. X minus 3. Yeah, 3.
Minus how much?
3.
All right, now what?
Set them both equal to 0.
Anybody know what x is gonna be here? Do I understand why x is gonna be 0? Yes or no? Now you can go through and divide both sides by what, 8 if you like. If you do class, you can get x squared equals what? 0. What's x still gotta be? What about x minus 3?
3.
So how many critical numbers we got, class?
2.
We got 2. Good? Now let's pose, I went to part 2. And I said, find all critical points, what would you do then?
Yeah,
Just plug it in. Plug it in where?
the derivative.
Plug it in where?
Oh, the 2x to the 4th power minus 8x.
So let's do this real quick, so y'all be clear. If you find the point on the graph, you put it back into the original equation. We good, class? Anytime you're trying to find a point, you put it back in the original what? Equation. We good?
Mm.
So in that case, this is part 2. That means we need to find f of 0, which is 2 times 0 to the 4th minus 8 times 0 cubed. Anybody know what the answer is?
0,
So what's my point?
0, 0, 0.
So you realize one of the points is 0 what? 0. We good? So now I got to find f of what? What's the other number?
3.
So that's 2 times 3 to the 4th minus 8 times 3 to the,
3rd.
so that's 2 times 3 to the 4th. What's 3 to the 4th?
27.
And what's 2 times 27? Someone said 54 minus, what's 3 cubed? No, 3 to the 4th is not 27.
It's 81.
It's 81, so this should be 1 what?
462.
And that's 8 times 27, which is?
216.
And 162 minus 216 is?
54. Negative 54.
So that means that point is 3 what?
Negative 54.
Anyone lost? Now, number 3 says, determine the intervals where f is increasing and decreasing. Now, how do we check increasing and decreasing? How do we check increasing and decreasing? She said the number chart. We put in the number chart. So we have the chart with the critical numbers using the first derivative. So that's going to tell me 0 and what? 3. We good? Alright, got 0 and 3. What do you do now?
Do the negative,
What do you want to test?
negative 1,
What about here?
2.
What about here? So we're going to find f prime of negative 1, f prime of 1, and we're going to find f prime of 4. Now remember, we're going to put this into the first what? Derivative. We good? So that's 8 times negative 1. What? What's the first derivative? Cubed minus 24 times negative 1 squared. What's negative 1 cubed?
1.
So this is negative what?
8.
8. And what's 24 times negative 1 squared?
Still negative 24.
You understand what's to be negative 24? So this answer here is negative 32, so that's negative. So what's the graph doing here?
Decreasing.
Because the answer is negative, I know it's doing what? Decreasing. Now if I put in 1, I have 8 times 1 cubed minus 24 times 1. So that's 8 minus 24. The answer positive or negative? That's negative what? What's the graph still doing? And if I put in 4, I have 8 times 4 cubed minus 24 times 4. And 4 cubed is? 4 times 4
16.
times 4?
32. No.
64 times 8? So that's 512 minus 4 times 24? Was it supposed to be squared? Yeah, class supposed to be squared. 24 times 4 squared? $300 and how much?
84.
Is the answer positive or negative?
Positive.
So what's the graph doing here? Now, since I asked you to find the intervals where the graph is decreasing, where is it decreasing at?
Negative 4. Well,
Negative infinity to where?
0.
Negative infinity to where?
3.
Do you understand why this is negative infinity to what? 3. It's decreasing here and it's still doing what? Decreasing. Where's the graph increasing?
3 to infinity.
We good? Everybody good with number 3? Now, part 4 says, find all relative maximum and relative minimum